there, and welcome back to Everyday Science Questions Answered.
Great to be here.
Today we're doing another deep dive inspired by the book 100 Everyday Science Questions Answered by Alessio Guarino. Some really neat stuff in there.
Absolutely. Those are those little everyday head scratchers.
And today's is one you've definitely seen. You spill some coffee, it dries, and boom, a ring.
The classic coffee ring stain.
Exactly. So the question is, why does spilled coffee dry to a ring? It seems so simple, but there's got to be some science hiding in plain sight, right?
There absolutely is. It's a perfect example of some interesting physics happening on a very small scale. You see it all the time, that darker edge and the lighter middle.
Yeah, totally familiar. So, okay, let's break it down. Where does this ring actually come from? What's the first thing happening when that coffee drop starts to dry?
Well, the process kicks off with evaporation. Simple enough, right? The liquid part, mostly water, starts turning the gas into water vapor and just floats away into the air.
Okay, evaporation. But wouldn't it just evaporate evenly? Why wouldn't it just leave a sort of faint uniform patch? Why the specific ring shape?
Right. That's the key bit. The evaporation isn't uniform across the whole drop. It actually happens faster at the very edges.
Faster at the edges? Why there?
Think about the shape of the drop. The edge, the perimeter, has way more surface area exposed directly to the air compared to the volume of liquid right beneath it, especially compared to the center.
Oh, I see. So more edges touching the air, basically.
Exactly. More contact points for the water molecules to escape from. So the edges start drying out quicker.
Okay, the edges lose water faster. How does that lead to a ring, though? Does the liquid move?
Precisely. Because the edges are losing liquid faster, new liquid needs to flow outwards from the center to replace it. It's trying to kind of, level things out.
Like a tiny current.
Yeah, exactly. A very small outward flow. And scientists call this capillary flow. It's a constant movement of liquid from the middle towards that faster evaporating edge.
Okay, capillary flow moving outwards, but coffee isn't just water, is it? There's all the coffee stuff in it.
You got it. It's a mixture. It's got all those tiny suspended solid particles, microscopic coffee grounds, oils, other compounds. That's what gives it the color and flavor, of course.
So this outward capillary flow, it's carrying those little bits along with it, like a tiny river carrying sediment.
Perfectly put. That outward flow acts like a conveyor belt, transporting all those suspended coffee solids from the center towards the edge.
And they just get dumped there at the edge.
Pretty much. But there's one more piece to this puzzle. It's something called pinning.
Pinning? What gets pinned?
The edge of the drop itself. As the water evaporates and this flow happens, the actual contact line, the very perimeter of the drop, gets sort of stuck to the surface it's on.
Stuck, like it can't shrink inwards as it dries.
Exactly. It's pinned in place. Imagine the edge digs its heels in and refuses to move back, even as the total volume of liquid decreases.
Okay, so let me see if I've got this. The edge evaporates faster, which creates an outward capillary flow, carrying the coffee solids outwards.
Yep.
And then the edge itself gets pinned. It gets stuck in place.
You've nailed it. That's the sequence.
So what happens then? Does that flow just keep going?
It does. For as long as there's liquid moving outwards and evaporation happening,
Sure.
that pinned edge becomes the deposition zone.
The deposition zone, meaning where all the coffee bits pile up.
Exactly. The capillary flow continuously delivers those solid particles to that fixed outer ring, that pinned edge.
Yeah.
And the water keeps evaporating, especially from that edge.
Leaving the solids behind.
Leaving the solids behind, concentrated right there at the perimeter. They accumulate more and more.
And meanwhile, the center of the drop, what's happening there? It must be losing its liquid to the edges.
It is. The center is the source for that outward flow.
Yeah.
So it loses liquid, and crucially, it loses the solids that were suspended in that liquid. They've all been transported away.
So that's why the center is lighter. There's just less coffee stuff left there.
Precisely. Once all the water has finally evaporated, you're left with that distinct pattern. A dark, dense ring packed with coffee solids at the edge where it was pinned, and a much fainter, lighter area in the center where most solids were carried away from.
Wow. That is actually really cool. Such a common little thing, explained by all these different physics concepts working together. Evaporation, capillary flow, pinning.
It really is a neat interplay.
Yeah.
And, while that's the core mechanism, other factors can tweak things a bit.
Like what?
Oh, the room temperature, obviously.
Yeah.
If it's warmer, evaporation is faster. Airflow makes a difference, too, like if there's a breeze.
Sure.
Humidity in the air plays a role.
Yeah.
The type of surface the coffee spilled on, even the specific stuff dissolved in the liquid, not just coffee.
Right. Different liquids might act differently.
They can, yeah.
Yeah.
But generally, for something like coffee or tea, which is mostly water with suspended bits, that faster edge evaporation tends to dominate, and you usually get that ring effect.
Okay, so let's recap the main idea. The edge of the spill dries fastest. That pulls liquid and the coffee solids outwards capillary flow.
Got it.
The edge gets stuck, pinned to the surface, so
Okay.
all the solids pile up there, forming the ring as the water vanishes, leaving the center lighter.
That's the essence of it. A fantastic piece of everyday physics.
It really makes you look at a simple coffee stain completely differently.
It does, doesn't it? Shows there's science everywhere.
Definitely. Okay, here's something for you, the listener, to think about now that you know about coffee rings. What about other spills?
Ooh, good question.
Yeah, think about spilling tea or maybe some juice or even, I don't know, watery paint. Do they always form that same kind of ring?
Or do they dry differently sometimes?
Exactly. Why might some liquids leave a different pattern? Maybe the thickness matters or what's dissolved in it. It's something to observe next time you have a little spill.
A great way to keep observing and questioning, keep applying that scientific curiosity.
Well, thanks for digging into the science behind coffee rings with us today. It was fascinating.
My pleasure. Always fun to explore these questions.
Join us next time for another question on Everyday Science Questions Answered. Keep curious.